One. Yep. There you go.
Okay, thank you. Okay, now I'm going to do this problem with you. This is on page 647, example 15.2. Alrighty. We did the ammonia reaction a while ago. Sorry about that. All right, now, the K for this reaction we said was 5.6 times 10 to the 5th power, which is a large K. What if we flip that reaction around and half that reaction? Let's see what we can do. So it's going to be NH3 gas in equilibrium with N2 gas plus, 1/2 plus 3/2 H2 gas. Okay, what is K for this reaction? We'll call it K1 again. Call this one K2. Well, since we flip the reaction around, I know it's going to be 1 over K1, and I halved everything, so I'm going to raise it to the 1/2 power. So then that's going to be K2 equals to 1 over 5.6 times 10 to the 5th power raised to 1/2 power, which is the square root of it. So take the reciprocal, and the square root of it, and you got 1.34 times 10 to the -3 for that value of that K. And notice, you know what I put a sticker around about units. We never put units on Ks, so you can't miss a point on these, okay? They're dimensionless quantities. Alrighty? Very good, very good. Okay, now, let's go on to, now I'm going to do example 15.2 with you real quick. Oh, I'll just erase this dude. Put it right here. Okay. Have 2 COF2 gas equilibrium with CO2 plus CH4, CF4 gas. And K for this reaction is equal to 2.2 times 10 to the 5th power. They want me to find K for this reaction. 2CO2, leave off the gases for convenience sake. 2CF4 goes to 4COF2. Now, I know K1 was this. K2 for this reaction, I flipped it around, so that means it's going to be 1 over K1, but I double the reaction, which means that I square it. You plug that in, and you get to end up with 2.07 times 10 to the -13, which is a very small K. Righty? Very good. want to do another one for more practice, right below that one that we just did. I got equation 2 here is CO2 plus H2 yield equilibrium with CO plus H2O. Now K for this reaction is 1 over that K they give me in that problem, 1 over, sorry, K equals to 1 over 1.0 times 10 to the 5th power. That's equation 2. Equation 3 was CO plus 2H2 equilibrium with CH3OH. K for this reaction, we'll call him, I have K1, I have K2, equals to 1.4 times 10 to the 7th power, just as he is written there. All right. If I want to do this reaction, if I add these two up, this equation 2 and equation 3, I get equation 4. So CO2 plus 3 H2s, 1 plus 2, those are on opposite sides, so they cancel out, yields CH3OH plus H2O. Now, how do I get K for this overall, this brand new K down here? Well, I flipped one of those around, and so that was 1 over 1.0 times 10 to the 5th times 1.4 times 10 to the negative 7. So K for this reaction is 140. So when you add equations, you multiply the K's. Bottom line. You add two chemical equations to get a third equation. The K for the third equation is the product of the other two K's. Got it? Okay. Very good. Now, start another section here. We manipulated K's. I'm doing section 15.4. On page 647. You follow along with me, it might help you. I have the reaction 2SO3 gas in equilibrium with 2SO2 gas plus O2 gas. The K expression, of course, is bracket SO2 squared times O2 divided by SO3 squared. Products on top, reactants on bottom, each raised to the power of their coefficient. Got it? Okay. That's how to write a K. This is called a Kc, by the way. Called Kc because these are molarities. Okay? Now, I'm going to do something different. Kc goes with molarity. Something new. Kp. Kp is a constant that we use partial pressures of gases. I could write this same expression up here as a Kp expression by saying it's the partial pressure of SO2 gas squared times partial pressure in atmospheres of O2 gas divided by partial pressure, SO2 and SO3 gas squared. These are partial pressures in atmospheres. All right? You can interconvert in between these things. For example, Kp equals to Kc times RT, open R, this R is the 8.31 R, raised to the delta N powers. Okay? Now then, let me stop this for a second.